Well, hello everyone, and welcome back to the radio shop. And we'll get started on our Kenwood TS520 SE repair series. And this will be video number 100. And I did have some other plans for video 100, but some parts did not come in, so we're going to have to make this video number 100. And in this particular video, we're just going to go through the 520 and see what it's going to take to get this thing back up and running, and you know what it needs, if it even can be fixed and got back up and running. You know, there are some unattainable parts in the radio, and it just depends on how bad the rust has seeped down into things also. You know, if it's just too much wrong with it, then you know we won't be able to repair it. But you know me, I like to take a challenge. A lot of people would look at this radio and say, no, we're not going to fix it, it's in too bad a shape. Well, I never feel that way. So anyway, sit back and we'll get into it, and you'll see some jumping around in the video because I've been doing little shoots here and there in the middle of working on other things. So, you know, I'll put all the segments together the best I can, and we'll hope that, you know, it'll turn out pretty good. But we got a lot of work ahead of us, and we figured that we might as well go ahead and start with the transceiver and see if we can get some life back into this old girl. So we'll get right on into the video. And the first problem I already see is I have the frequency counter connected, and you can see that it's reading 90 megahertz. And also you'll see that the VFO light is not on, and we are in the VFO position. Now I went ahead and sprayed the pots. That did not take care of it. So with there being a 90 on the display, this is telling me that some oscillators are not running. So the radio is not going to receive or transmit in this state. So what I'm thinking is either going to be this function switch has gone bad. There's a problem in the RIT switch because it does run through there. Now I do have the plug into the back of the VFO accessory, so I know that's not the problem. So there's nothing telling the VFO light to come on. So this is telling me that the low voltage circuit is probably not working, or it's not passing through the function switch. Alright, so we're trying to work through the problem where we don't have any VFO light or RIT light. And if we look at the circuit right here, I'm sorry for the poor quality of this schematic. It is terrible, but it's the best I have. So you have to trust me. You can see 3 LEDs here, and this is the VFO indicator. It comes out VFO, goes through the RIT switch, travels right over. Now this way goes up over here to the VFO itself. So we're going to travel right on around, and it is going to end up right here on pin 9 for the VFO socket. Then it comes back around. It goes all the way back around. The schematic is so poor, it's just hard for me to show you each little line on it. But anyway, pin 8 comes right on back around to S2, wafer 2. And then as you turn it, that completes the circuit. So we need to buzz out that connection and see if we're getting any continuity to the VFO jack on the back. So you know, your first thought would be rust. It's probably gotten into these pins. I've got the VFO jack loose and I can see pin 8 and 9 here. So what we're going to do is just buzz out to the function switch that I have pulled out, and then we get right down here to the RIT switch. And it looks like we got continuity on this one. Make sure I won't touch something else. Yeah, we got continuity there. So I'm going to come up to this red center pin on the RIT switch. And we have continuity there. It really makes me wonder about this function switch. Now you can see here our function switch here, and here's the to read out how this function switch is laid out. And we have a one wafer here. It's going to be S2. We're going to have 1, 2, that's number 4, and number 3 is way up here. I don't think y'all can see that, but that's number 3 way up here. So we're probably going to have to tear this function switch apart, if nothing else, to clean it. The way this thing's designed, sometimes spraying contact cleaner or deoxidant, it just will not do the job. So we'll have to get into that and look at it. As we can see here, part of our indicator board, you can see this area here is the indicator board. Now this is a split schematic, and it just happened to be split here, but right here on the edge you can see D1, which is our VFO light, our RIT light, and our fixed light. So you can see this runs right through the RIT switch, and then off to the VFO itself, and then it's going to go around to the accessory plug-in and back, and then back down and around to the wafer switch number 2, was going to on S2, which is the function switch. So we're going to have to look at all this here and do some buzzing out through it and checking, and also check our low voltage supply. We should have 14 volts going into the fixed channel AVR board, which is right over here. So we got to make sure that, you know, we have our 14 volts coming in, and that's going to go through the circuit. And this is an adjustable voltage regulator, and then it should come back out with 9 volts that feeds our circuit. So we'll have to look at all that, and we have to make sure we got our 14 volts coming from our supply. So we'll get right on into it and tear everything apart and go into it, and I'm going to do it just in little segments, and we'll go through and see what we can find. So we're under the radio, and part of my troubleshooting process, we noticed that we don't get no VFO or RIT light or anything. Well, all that comes through this one function switch that changes it from fixed, VFO, and all this stuff going through it. Now I've already started taking this apart, and in this wafer I have noticed each wafer has a little metal contact that makes continuity between the inner board and the plastic holder, and there's terminals on it, and you'll see more about it once I get this out. But I can already see one of those contacts is gone, so I think somebody's already had this apart and have took that contact out or lost it. And you know, I can look through the gaps here and see the contacts in the other three. So I got to completely you know, go through all this here and write it down and take plenty of pictures and get this function switch took apart or unwired so I can lay it out and take it apart. Because if they done that, there's no telling if the rest of these are in place where they should be. The thing is, there's not really a good schematic on this function switch assembly that I've been able to find. But worst of all, I have to see, can I find a function switch out of a junker somewhere, if anybody, you know, would have one. But we got to get it apart and get all this cleaned up and see what's going on. Now I probably can make that contact. It's just a spring, it's like a Z bend. I'll show you here that on the paper here. It's made kind of like that, but it's real small, and one end is kind of folded like a box, and that holds it in that little round wafer that's got little square holes cut in it. Now each one of these little disc in here has 4 slots in it for the spring contact to fit in, but they only use 1 per disc. So maybe that's something I can make. I've done looked through some other old radios and I have nothing else in the shop that's like it, so we'll just have to see. But I'll go ahead and get all this tore out, and yeah, as you can see, it's a mess. And one thing I've done, I went ahead and drew a line with a red paint marker across the whole mechanism. That way I know which way that everything went. Okay, so here is our function switch, as you can see. And what I do is I've got various holes in the bench here, and it's for doing stuff like this. So the function switch just sits in there, and then I start disassembling one at a time. You know, the washers, the 2 washers, the end cap, the first set of contacts, the rotor, the next bakelite board, 2 spacers, and then right on down. And you can see here sitting on this one, I don't know if I can focus on that because the thing is so little. You can see this little tiny spring clip right there, and it fits in one of these slots, and what it does, it connects from this side to the contacts on the back of this board. Well, the first one is missing. I don't know if it wore out and fell out, or someone has been in it and took it apart. So that is why we're not getting a VFO light. Also, you can see just, oh come on, you can see how corroded that those terminals are. They're pretty much corroded and needs a good cleaning. Sometimes even spraying deoxit in something like this won't even take care of the problem. So I've got to sit here and clean all these and see if I can find something to make a spring contact to go back inside of there. I'll get this under the microscope in a bit and show you just exactly what that contact looks like. What I want to do is show you just how tarnished this is. And you can see all the black around the ring here that makes contact with this little pin. I mean, it is just terrible. And I'm pretty sure this is why there's so much of a problem in these function switches. And this makes people just give up on them, because most people are scared to take them apart. But anyway, we'll see what we can do with it. Now you can see how nice and shiny this is now. And I used no chemicals or nothing on it. All I used was a piece of Scotch-Brite pad. And just hold it on there and rubbing it back and forth, you know. And that has just got all the tarnish off of it. And now it makes a good electrical connection. We'll have to go through all the rest of it to do the same. So what we have here on the bench is just a piece of wet dry 1500 grit automotive sandpaper. Make sure it's pretty clean on the back side. I'm going to take just a little bit of contact cleaner and just wet the surface. Then we're going to take the little tiny contact, and I'm going to have to put this under the magnifying glass so I can see it. We'll polish one side. I know my hand's in the way, sorry about that. And we'll polish the other side. You'll see that the contact cleaner will dry up pretty quick. But now our little spring contact is good and clean on both sides. So I did the contacts on this basically the same way with some 1500 grit paper, and using my finger and going there and just cleaning them, getting the tarnish off of them. You don't want to sand it down, you just want to get the tarnish off and get them nice and clean. Now I'll wash this down with some cleaner and get it installed. You know, pretty much what this is just restack everything back the way it came off. So see, this board would fit over there, but before we do that we got to clean this one. I'll hit this with a little Scotch-Brite. Get all that old tarnish off. This radio has definitely been around a lot of moisture. As you can see, places in the radio, like on them nuts right there, have moisture. So you can pretty much imagine how the contacts look. It's been in moisture, it's they're going to be tarnished and corroded. So that'll go on. We'll drop a little disc on. Now everywhere there's a spring contact, I've marked the hole that it came from. As you can see, there's 4 holes in each one of these discs. So you have to mark the one that the contact come out of. Then when we get down to that last one, we'll see if that's going to be a deal breaker or not. These little things are Peter to get in. And trying not to drop them. If you drop one of them, it's gone. And that's probably what happened to the one that was missing. Okay, let's make sure we got it the right way in there. Okay, she's sitting in there. Now I'll go ahead and clean this one and put it on there. Well, I'm down through the whole stacking on the last one where we don't have a spring clip. So I'm going to play around with a few things to see if I can make something that will sit down in there. And since the other ones was all in the same place, I'm hoping this is going to be the hole that it's supposed to be in. I'm trying to look at the schematic to make sure, but it's just hard to tell. So, you know, it's just going to be trial and error. I sure hate to put it together and it's in the wrong hole and got to take it back apart. The easiest way, you know, is to completely unwire the thing and then put it back together. But that may be a bit of a pain. We're looking at the function switch, and you can see, I'm sorry, looking for my wrong corner. Okay, right here you can see our function switch is S2, and it consists of several wafers. There's 4 of them exactly, and you can see that's S22, the S21, S24. And if we scroll up on the schematic, you can see what over there is, that's S2-3. So that's all 4 units of our wafer switch. And it's kind of a giveaway because you can see we only got 1 contact, and this one is on the 2nd pin on S3, so we know we can easily find out the orientation, but every one of them are pointing to this 1 pin. See, they all point to that 1 pin on that side, so that tells me that the contact was in the that all 4 contacts are in the right location. We know where the other 3 were, and now we know where the missing one goes. I don't know, but we may be in luck. I had picked up a Cobra 29 a while back that had some kind of channel mod in it, and it had crystals up here. And I ripped it out and put the radio back to stock. So I've desorted the little crystal board. And this almost looks like the same type of wafer switch. So I'm going to tear this apart and just see what we got. We may be in some kind of luck. Check it out. Get some light up here. Not only does it have the spring terminals, there's 4 slots, but this one happens to have 3 in the rotor. So this will give me some extra ones in case we need some down the road. And I've had several of these switches like this. So we don't have to make one. I'm going to dump these right out on the table. Come on, you can do it. These are little standoffs. And these are just about identical to what's in them. And the difference is in this switch, the ring is cut into quarters. So there was a switch, you can see this one corroded, won't never used, but the other three were. So that should help a whole lot. Okay, so I went in and buzzed out all the terminals to make sure that we got continuity. And as you can hear, we do. So all these switches are working like they should be. So now the painstaking step is to go in there and connect all those wires back to the switch. Oh, the agony. And as you see, I'm sitting here putting one wire on at a time and getting them back where they're supposed to be. Now you have to watch out because some of these wires are the same color. Like I have two orange wires, we have two green wires, and we have three white and red wires. So that can cause a bit of a problem. So what you do is you just take the wires that come off of one switch and you bind them all together. Then the rest of them you leave separately. This way, hopefully, you can keep them separated so that, you know, you don't get the wrong wire on a terminal. And what I'm just doing is just doing the hook and bend method. Back into the terminals. And as you can see, that one decided to come out. This one terminal has two wires, the orange and the purple. If you get the hook in there and then crimp it over, most of the times it'll stay in. This time it doesn't want to. But that's okay. We'll get it licked. You're working on these, don't use too high a heat neither. Because you got to remember some of this is in plastic. And you don't want to melt that plastic former. This is some of the stuff y'all usually don't see that we do off camera. But I just want to give y'all an idea of the tedious work we go through sometimes working on this old equipment. Yeah, at times it ain't all fun and games, that's for sure. Okay. Yep, fun, fun, fun. Not too many more to go though. We're getting down to the end wafer, which has quite a bit of wires on it. But then you got wires that go in and they cross and go to the second wafer, and then a wire goes in this way and it crosses back the other way. Yeah. We're going to soon have this one licked. Alright, I got an orange wire here. Get it untangled from all this spaghetti. And this orange wire is going to route down here to the bottom. I probably should be looking at the schematic or my hand-drawn diagram. But I'm feeling a bit confident today. Or I'm being stubborn. One of the two. It's about time to clean the tip. There we go. Yep, so we got that one on. And we got a red wire. I'm trying to get all the wires so they line side by side as they're going down there. So this red wire is going to come all the way back here to the back. Get that hook a little better. And it's going to hook to this bottom side. Pinch that in. It would be so much nicer if you could have the switch sitting down on the table and hook the wires in. But these wires just run all over the place in here. So I guess that wouldn't be too fun either. Yes, so we're getting down to the nitty gritty now. And I'll show you a little something here. So you're looking at the switch. This is one wafer. And it's got 6 contacts across. I'm not going to draw but 3. Then you got another wafer, and it's got 6 across it. Well, one wire goes into this hole, but it crosses over to this one. Then the next wire goes into this terminal, and it crosses over to that one. That can get you a little confused, but it's all good. I'm going to have to make this a little bit longer now. Yep, that'll be fine. And we got to put an insulator in it. So that the other wire going across doesn't short to it. Okay, back to the tedious stuff. So I really want to put in more cameras, so that when we're doing stuff like this, we can get several angles on it and make it so y'all can see everything that's going on. But more cameras cost money, and we don't always have the money to do stuff like that. Maybe one day. Alright, got that one in. So we'll hook the back terminal and go ahead and solder the end. I can't solder the outer terminal because another wire goes in there with it. Okay, now we can put the other one in there. I was wondering why that wire was a little short. That's because I used the one that was just supposed to be stuck in there, but that don't matter. They're both hooked to the same terminal. I'm not really sure how much of this I'll put in the video. I don't want to bore you guys too much. Okay, 2 more wires to go. I'll have to get this one straightened out because this got to go through 2 terminals, across the other terminal. And it's a bit difficult with this other wire coming through here. So one right here on top. Okay, that one's in place. Got it sorted on that side. I think I was ghost soldering then, it won't really go nowhere. Okay, and the last wire. I'm pretty sure the next thing we're going to have to do is start checking some voltages. At the moment I'm not really convinced that it's just a function switch. Most of the time it never is. Alright. Stuff out of the way here. I'm not going to mount the switch yet because I can check voltages here. And let's see, straight up should be 2, 3, 4, 5, 6. It should be somewhere around VFO. We'll put some power to it. I don't know how much of this y'all can see. And we'll see if we get anything. Still nothing. But at least we got our switch functioning now. Cause I noticed that I was getting some voltage on one wire, but it wasn't coming out the other side. And that was because of that missing pin or spring clip. Okay, so now what we're going to have to do is trace all the way back up and see if we can't figure out why these lights refuse to come on. While I'm down here, before I go any further, I'm also looking at the RIT switch. And we are seeing some problems there. I got the button in the off position. We go to this side. We had continuity. When we go to the bottom side, we're not getting nothing. I push the switch in, we'll go from middle to the back side. That's working. Go to the second set of terminals, and that's working. So in the outer position here, the green and the yellow wire has no continuity between them, as you can see. Nothing. But the white and the red wires do. So we know that switch is dirty. I've already tried spraying it. That didn't take care of the problem. Okay, I just want to go through this with you. Here we have our rectifier unit, And what we got to have is the 14 volts to run all the stuff in the radio. And it is converted down to 9 volts in the fixed channel board through the AVR, which is the automatic voltage regulator. So I wanted to come here and check our 14 volt rail. And we'll go to AC. Get these lights off that meter some. Hoping y'all can see this okay. And we have 13 volts AC. So I'll remove the wire from pin 14. You can see right there, and there's our wire. Now, Kenwood in these radios did the wire wrap method, but I'll just loop it back on and solder it back on after it's fixed. But I got that removed so there's no load, so we know that nothing can feed back into it. So looking at this, I think the best thing to do is go ahead and pull this rectifier unit and go through the 14 volt DC supply. Probably go ahead and replace these 2 caps while I'm in there also. Even though the DC 14 volt DC supply does not have a capacitor on this board, it is located somewhere else in the radio. You know, we got to have 14 volts on this wire to run to our AVR unit fixed channel board, and that will turn on all the other circuits. So what I'm going to do is supply 14 volts DC to this wire. This is our 14 volt going throughout the rest of the circuit. So I'm going to go ahead and apply 14 volts to that. And when I do, I'll let you watch the meter. Okay, as you can see, our meter is sitting on 14 volts. And I verified that with the voltmeter. And our amperage is sitting on 0. So when I connect the 14 volts to the lead, we drop back to about 9 volts. And the amperage meter comes up ever so slightly, about 1/4 amp. Well, I got it set at, so because I'm current limiting, I don't want to put too much into it. I do see our VFO light illuminating. Now I could give this a little more current. I need to figure out just how much this circuit needs as far as current. So I'm going to reset the meter. We'll put our shunt in, turn it back on, and we're going to go to about 1/2 amp. We'll turn it back on. I don't want to blow the back end out of anything, that's why I'm keeping the current low. Okay, we're holding a good solid 14 volts at 1/2 amp. And I'm showing probably about 3/4 of an amp there. And you see the voltage is holding. Our VFO LED is illuminated. So we're looking here at the board layout on the rectifier unit, and we can see these 4 diodes over here in a full bridge wave configuration. Our AC comes in, we have our 4 diodes, and we get our DC back out right here at terminal 14. Again, there's no capacitors in this circuit. Okay, so looking here at the schematic, you can see our 4 diodes right here. Our AC voltage is coming in this side, and if we follow this around, we can see we come to a 2 amp fuse. Now that's one capacitor, C22. I'll write that down. It could be a suspect. And you can see that also feeds the auxiliary jack for accessories like the digital display. We come up here on the other side of this, we have C21. Now remember, there's 14 volts on this line, and you can see both of those capacitors are 16 volt. We come up here and we have a bypass cap, which is C40. And then we'll go on up into our circuit. So we probably just need to go ahead and check these capacitors on this line also. But the thing that worries me is that with our 14 volts, both on AC, I can see nothing else tied to the 14 volt rail. So I went ahead and just rebuilt the supply basically over here for the low voltage 14 volt rail, and I just went ahead and installed some new diodes and cleaned the board up. Now when I took the other diodes out, you can see them there on the board. 2 of them fell completely apart. They just crumbled when I was removing them. So those diodes were probably open, and this is why we won't get the 14 volts DC out. But I didn't have these 2 capacitors, they're 33s at 160. I have nothing around that value in the 160 range, so I'm going to have to order those. In fact, I'm going to go ahead and order a complete capacitor kit and go ahead and get them up. I didn't video rebuilding that supply. It was just so aggravating getting in there to work with it, because you don't have much room in here, and you had to disconnect the high voltage lead going down here to the cap just to get the board up enough so you can get to the back of it. It's a little bit of a pain to get to, but it wasn't too bad. Okay, so this is when things you just have to go back to the basics. And what I've done, I've got a jumper clip on the DC output, and I got a jumper clip on ground. And I've got a resistor. It's a 22K quarter-watt resistor, and we'll look at the voltage now. And we're at 10.79 volts. So at this point, I just want to see if we got any life at all in this radio. When I turn it on, I plug the external speaker on. We have a VFO light on, and you can hear we do have some AF gain. I've got the turn this back down, single generator set to 14.200, and that is on AM. So all I want to do is see if this time if we have any single at all. And you can tell how dirty the controls still are. That is a good sign. That makes me happy. I almost want to do a happy dance. Pardon the noise. That's at about minus 90 dBm, which is about 0.03 microvolts into this receiver. And as you can see, it is here in the single on the 20 meter band. I've got about a one on the S meter. Oh, that is just great. That makes me very happy. Now we know we do have life in the receiver, and it's receiving pretty good. That's a real low setting at minus 90 dBm. So I think mostly what we're going to have to do is finish cleaning all the controls in here and getting all that done, and going back and checking some grounds. Anywhere there's a metal screw holding something to ground, that basically needs to be poured out, cleaned, and put back together. If you notice our separation plates under here and the band switch, you can see this rust that's accumulated on these shields right here. You can see it right down in there. I don't know, but I might end up, I may just end up having to pull this whole section out, top and bottom, which will be quite a bit of unwiring, but it may be necessary to just get everything good and clean. And what I usually do is pull it out, pull your band switch out, mark all your wafers where they are in correspondence with the band switch, pull it out top and bottom, soak the whole thing in some a bucket of water with either some Palmolive or Dawn dishwashing solution in it, and let it soak, and take it out and dry it, and blow it out real good, and put it under some heat and let it dry out real good. And that'll give me the opportunity to go ahead and clean the rust off these plates and treat them. Again, that's a lot of work, but we may have to do it because we want to make sure that there's no corrosion has gotten in these coils. All these are your oscillator coils. I think this is 15 through 160. Yeah, 15 through 160, and your 28 megahertz coil down here. This is your mixer section here. This is all the mixing is going on. Antenna section, and this is your driver section. It's 28 megahertz down here at the bottom, and then 15 through 160 up here, and this sets your drive for each band. But I'm just happy to see it going this far. Now, you can overlook a lot of things and not do it. If you don't do it, it's going to come back and bite you later. So, when you're restoring a radio like this, it's best to go ahead and do it all at one time. I'm probably going to go ahead and just order a whole complete recap kit, and go ahead and just recap all these boards and the two main filter caps, and go ahead and get all that replaced sometime here shortly. We can see, I was talking about that corrosion. Let's see, you can see the screws in there are rusty. If them screws are rusty like that, they're not making good grounds. Even that brown wire that's wrapped around that terminal. It's gonna go out of focus on me. Trying to get a better close-up on it. That's green corrosion on that. Now again, Kenwood didn't sort a lot of wires. They used wire wrapping on them. So, you know, whenever you see that connection is going to fail. It's just a matter of time before it does fail. So all that stuff has to be cleaned up. Yeah, it's a lot of work. And most people would look at it and say, nope, I'm not going to have no part of it. We'll scrap it out and use it for parts. There's a lot of these radios made. And there's a lot of them has been scrapped out for parts. You can find them on eBay all the time. So anytime I get a chance to save one, that's what I'm going to do. I very, very seldom get a parts radio. I do have a Yaesu FT221R that is a parts rig, and that's because when I got it, it was already a parts rig. So, you know, I very seldom scrap out any radios if I can help it. We can see here under the PA board, I just want to have a look at our cathode resistors. And we can see the 2 resistors for that one and 2 resistors for this one. If we measure them, they should be about 5 ohms if they're good. One good sign is, I've got wires tangled everywhere. One good sign is that I'm not seeing any charring or black resistors. That one's checking at about 4.6. And that one's checking at about 4.9. Zoom in on the meter so y'all can see that. That's up to about 5.1 now. If we go to the other one, .7. So that is a good sign that our tubes may be good, since the resistors are not bad. Well, it is early morning, and I just wanted to run through the band on 20.
K5 LBJ, DQ, DQ, DQ.
K5 LBJ from WA9 Foxtrot, Foxtrot, Victoria.
Foxtrot, Foxtrot station, say again.
Whiskey Alpha 9er, Foxtrot, Foxtrot, Victoria, 5 and 9 up in South Shore Lake Superior Road.
Whiskey Alpha 9, Foxtrot, Foxtrot, Victor, you are 5-8 into Austin, Texas, planning Reed, Romeo, Echo, Echo, Delta, USL.
Roger, Reed. The original station here in the handle is South Delta, Oscar, Uniform, all over.
Judge, we are a full of roundup, so thanks for the contact number, feature.
You see, we are receiving.
NCAA had their tournament here in Kansas City too for many, many years. NCAA used to be headquartered here in Kansas City, and they picked up and moved off to Indianapolis here about 15, 20 years ago. So it's always been kind of a big deal here. And still the NAIA still is around, and they still have a tournament here in town. Not as big as it once was. But some pretty good basketball been played, and we enjoyed it. We were very happy to host the NCAA tournaments and also NAIA tournament. But those days are long gone. We're lucky to get a regional game now in the NCAA.
On 20 meters.
But
And length, but like
KU plays a couple of games a year
9 o'clock
over
in the morning.
our spread center here in downtown Kansas City. And I've been to a couple of those games. They're very nice. It's a big arena. Holds, 18, 20,000 people.
I can't tell you if the estimator's completely adjusted correctly.
The field house over at Lawrence, Kansas, where Kansas University is, holds about maybe 12,000 people.
From the way the signal sounds and
it's pretty,
looking at the estimator, he might be bumping a S4. I would say the estimator is out of calibration.
Because they sell it out all the time. They always have a full house there every game. And there's never a seat left vacant. So people are pretty big about it here, Dan. Listen, I'm going to run along too. I need to get my day started here, but good to hear you this morning, and certainly keep an eye on things down there in Georgia. Don't let it get out of hand now. In for GNR, K0VXU.
It's not bad for early morning 20 meters. Usually this band don't open up that good right here until after lunch. I went ahead and connected the digital display, and as you can see, it's working. Grab another knob here. I ain't even touched the driver, but you have to tune that for, your pre-select. Oh yeah, they picked it right up. It's just as any activity down on 40 meters. Tune our pre-select to the lower sideband.
Edward, I had never seen such a mess in my whole life. I mean, when I say it looked like a monkey wired, it looked that way. And I was shocked because everything I had prior to that time was just really, really good. And anyway, so
pretty nice single.
But I'm sure. Anyway, I sent it back. They give me my money back. But that thing was dead on arrival, and there was no way. I started looking at it.
Still got to calibrate the meter.
Get in here and figure out what's wrong with it. Once I looked at that wiring, I said, this thing is just, oh my gosh. But I don't think that's the case now. I think that, I think. That's a brick that's probably maybe 20 years old. So
I didn't realize I was on the 20 meter beam.
They last a long time, salt state stuff.
I switched over to the 40 meter dipole.
I appreciate you breaking in and letting me know about all that. That's too bad about the transmission. I sure hope that
Sounds like he's dropping out some now.
continue to work okay for me. They look like when I open them, they're well made. Yep.
There's CW down there. Some 80 meter. Thought I heard a little something there. On the weekends, around 38, 90. Quite a bit of activity here, but nothing today. Not on a Monday. Yeah, but I'm very happy with it.
Hello, good morning to you, 5 and 7, over.
Alright, now that we know that our receiver is working, we'd like to go ahead and check the transmitter. And we're going to go to upper sideband, carry about halfway. I peaked the drive already for maximum noise. We'll go to IP. And I'll zoom in on the meter a little bit. Oh, that glass is really shiny. We'll hit send. And we're at about 60 milliamps, just what it needs to be. Let me just make sure the bias will adjust. Yeah, just good. Okay, now that we got that done, we know that our current is right. So what we want to do now is go over to tune. We'll set the meter to ALC. We'll pick our drive control over here. Good power out. Okay, we got our drive peaked. We'll just go back to IP. We'll leave it in the tune position just like it is. And what we're going to do now is take this plate control and dip the plate. What that means is that we want the lowest meter reading. And sometimes on a dummy load you don't always see a big pronounced dip. You'll just see a little small dip. So we'll go to send. And it's so minute you can hardly even see it. But it was a little fine dip there. Alright, what I want to do now is go to RF. We'll switch over to CW. And we're going to tune the load and the plate back and forth for maximum output on the meter. So we'll hit send. I'll touch the plate up. And we'll hit the plate and back onto the load. And you can see the meter really goes over there. And that's peaked out about as much as we need. Let's have a look at the watt meter. Okay, I have the old MFJ on the 2000 watt scale. So you'll be reading the top scale, 0 through 2000. And we'll flip the switch. And we're showing about 120 watts. And it's holding pretty good. And that looks real nice. Now the only thing we haven't really tested on this radio is the audio circuit. Well, this is the microphone that comes with it. And you see it's the Shure. The model 526T Series 2. This is an amplified microphone that has a battery in it, an amplifier circuit in it. And we have a control on the top. I'm going to set it for about 5 because we don't really want to drive the radio so hard. And we'll put the radio on upper side band. We'll go back to our MFJ meter. I haven't even checked the mic circuit, so I don't even know if it works. I'll run the mic gain at about 5 also on the radio. We'll key the mic. Test 1 2. Radio test 1 2. And as you can see, we do have modulation. So the audio stage is working in our TS520. So we just look at our meter and we can see that our audio is staying in the ALC range. And if I start turning this power mic up just to have a look at it, and we're still in the audio, the ALC range. Alright, mic gain on the radio is to maximum, and still within the ALC range. But you know, it's where you need to monitor it to see if you're flat topping or anything. Okay, I'm gonna turn on the processor, and we can see it come way up, and we're just about to exceed the ALC range, but it's not looking too bad. So as you can see, our 520 is not in too bad a shape. It just needs, you know, some TLC here and there, and clean up some stuff, and you know, just make sure that we got good grounds and connections throughout, you know, the whole radio. So I'm sitting here with the external speaker, digital display, and the VFO all connected up, and turn the VFO back off. Bring up our gain.
25 years ago, a witch called Ubin, tremendous number 4.
Okay, if you notice, I'm able to tune in a station here, so that's the only thing I can find at the moment, some foreign station. But when we go to VFO, we're on 14.216. When we switch over here to the external VFO, I'm not able to
well, very well known radio operators, because they trouble.
As you can see, it was very difficult just to tune that station in on the external VFO, and I'm noticing a little backlash in the system, which tells me that one of the springs is not set right in the gearing. or we got a lot of bad connections. Now you got to remember that that capacitor is sitting on 2 pivots, and it's supposed to be grounded, and it's got little spring clips in it that cause it to ground so that it can rotate freely but still ground it, and they're probably dirty, but that'll be for another video. Anyway, this is going to be all on this video, and we'll pick up some more videos because we still got lots and lots of work to do on this. This was just, you know, preliminary checks and getting it up and running and see what it had to have. Now we can get all the fine tuning and stuff done. Anyway, if you like the video, please give it a big thumbs up. If you'd like to discuss it, come over to the website, and we'll have a thread started over there already on repairing the 520, and I'll be posting some pictures and some tips and this and that and problems that we found throughout the repair series. Until then, we'll catch you next time, and we always like to hear your comments.